Good day, viewers all over the world. You are welcome to Toilet Online Class. Today, we want to look at the type 3 partial fraction, where we have nonlinear factors that are not repeated at the denominator. Look at what we have. Look at what we have on the board. We are given 10x squared plus x plus 9 all over x into 2x squared plus 3. We want to resolve this into partial fraction. Of course, x is just a factor, it's a factor. So we say a all over x plus, look at what we have in the second bracket, in the bracket, 2x squared plus 3. You cannot factorize this. So this is non-linear, it's not a linear factor. So this one cannot be factorized, it's non-linear. So how do we resolve this non-linear? Since you have the highest degree here is 2, then this is what I will write at the numerator. Instead of writing b, I will say bx plus c all over 2x squared plus 3. So if the highest degree is cube, 3, s cube, then I'm going to start with as squared plus bs plus c. So that's how to resolve partial fraction that involves nonlinear, like what you have here. So at this point now, we have been able to write this. So we want to find the unknown, a, b, and c. So if I multiply through everything by the denominator of the left-hand side, I'm going to get 10s squared plus x plus 9 here will be equal to, if x you cancel x, I'll be left with this. I will have a into bracket 2x squared plus 3. Then plus bx plus c. So if 2x squared plus 3 cancel this, I'll be left with x. So into bracket x, that will be multiplied by x. So at this point now, we can resolve this either using cover-up method or completing the square method. But I think I'm going to use comparing coefficient method. So I'm going to use method of comparing coefficient here. We can also use cover-up method, but method of comparing coefficient is advisable when we have nonlinear factors. So it is advisable to use method of comparing coefficient. So 10x squared plus x plus 9x. If I open up here, I'm going to have 2a x squared plus 3a. Then if I open up here, I'm going to have plus bx squared plus cx. So let me collect the like terms. I have 2a plus b. These are the one with x squared into bracket x squared. So let's see the one with ax, then plus cx, then plus 3a. So now let's compare the coefficient. 10x squared plus x plus 9 is equal to this. So when we have x squared, what is the coefficient of x squared at the left hand side? This is 10. What is the coefficient of x squared at the right hand side? 2a plus b, equation 1. Then when we have x here, we want to compare the coefficient. What is the coefficient of x here? Is 1. What is the coefficient of x at the right hand side? It is c. So c is equal to 1. Then we go to the constant. When we have the constant, it is 9 that we have here. 9 is equivalent to 3a. That's what we have there. So it's 3a that we have at the right hand side. So we have 3a at the right hand side. If you divide both sides, this is 3a. So you can say this is equation 2 and this is equation 3. So from the 3 equations, we can go ahead and solve what we are given. So now look at, so in this case now, from equation 3, we know that 9 is equal to 3a. Let's divide both sides by 3. 3 will cancel 3. So a is equal to 3. A is equal to 3. We have gotten the value of a. Then from equation 2, we are given that c is equal to 1. We know that a is equal to 3, c equal to 1. Then I can go ahead and find the value. I can go ahead and find the value of b from equation 1. I will just say substitute a is equal to 3 into equation 1. What is equation 1? 10 is equal to 2a plus b. So that's what we have there. So if that's what we have there, then 10 will be equal to 2. A is 3. 2 times 3, that's 6. I'm going to have 6 is equal to b. Then 10 minus 6 is equal to b. B is equal to 4. So we have gotten the value of b to be equal to 4. So we have gotten the value of all the 3 unknowns. Then what will now be the sum of its partial fraction? We just come here and substitute. What is a? 3. That will be 3 all over x plus, what is b? B is 4. I'll say 4x. C is 1 plus 1 all over 2x squared plus 3. So this is the sum of its partial fraction from what we are given. And that's what we have done. Thank you.